Hello everyone, welcome to Prime Number. Today, I'd like to talk about the Bitcoin transactions. In previous episode, we talked about how does the Bitcoin work by using a use case that Alice wants to send Bitcoin to Bob. It's starting from using Alex's mobile phone to send a transaction to any of the Bitcoin network node. But we didn't dive into what the transaction looks like, what in the transaction, and how to pay the transaction fees. In today's video, there could be more information, a lot of concept. We also talk about the script. The video may be a little long, but it is very informational. Now, let's take a look. What is a Bitcoin transaction? A Bitcoin transaction has two main parts we call the inputs and outputs. So this is the input and this is output. The list of inputs referencing to the previous transaction's output. So for example, Alice want to send, let's say, 10 Bitcoin to Bob. So using this transaction to do that, so the Alice need to reference to a previous transaction output, which prove that Alice has more than 10 Bitcoins. So let's say this is the index 0 input, which references to one of the output, let's say index 1 output from a previous transaction, and it only have like 5 Bitcoin. So that the Alice need another input which may coming from another transaction output, which for example is from index 0. It has like 8 Bitcoin. So in total we have 13, so that it has enough Bitcoins. So the output is Alice send it to Bob. So the index, for example, we should have two output indexes. One is this is to Bob, and this is 10 BTC. Since we have in total 13, so the rule is you have to consume all the inputs to come up with the output. So in total we have here 5 plus 8 is 13. So we have, this is 10. So we need another 3. So usually the wallet will create a transaction which will pay Alice itself with, usually it should be 3 BTC to Alice, to herself. But in reality, those kind of transaction will not be picked up because it doesn't pay the transaction fee. So in reality, it usually would come up with, for example, 2.99 BTC. So that would be 2.99. So in total is 12.99. And there's no field such as for fees or transaction fees. So the difference from the input and output is the transaction fee, which the miner will take it. So you may have in mind that the blockchain is appended one by one. The block is referenced to the previous block. So don't be confused the transaction reference with block reference. It's a totally different concept, because this could be a block with multiple transactions, but this may not be the previous block. It could be 10 blocks away or even thousands of blocks away, and this may be even farther, maybe thousands of blocks away. So the reference of the transaction exists in parallel with the reference of the blocks, and there's no relationships. So you may be wondering, so since Alice wants to send coins to Bob, so it seems there's no easy way to know like the balance that Alice has. So when the wallet want to create a transaction, and the Alice want to send Bitcoin, want to send 10 Bitcoins, the wallet doesn't know how much Bitcoins, how many Bitcoins Alice has. So it has to go backward to check the unspent output for any transactions which sent to Alice and add them up and see whether Alice has enough balance. So it is not efficient at all. You could go backward until the Genesis block just in order to know the balance of an identity, of an account. Let's say Bob wants to send Bitcoin to Charlie, and so the Bob can create another transaction which the input is referencing to the output, the index 0. So it could only have one index. For example, only Bob now has already like 10 Bitcoins, and he only wants to send 5 Bitcoins. So only one input is needed. So that will add up to, this is 10 BTC, because the output of the previous transaction sent to Bob has 10, and the output is, there will be two output. One will be to Charlie, that is 5 BTC to Charlie, and another is to Bob himself. That would be close to another 5, but since the Bob need to pay the transaction fee as well, so Bob will get 4 something BTC back. So this is basically how the transaction is in Bitcoin. Let's take a look at the real transaction in Bitcoin. I randomly pick up a transaction which is almost 2 years ago, is because nowadays the Bitcoin has upgraded to support the segregated witness transaction. It's a little bit different from the transaction we just talked about. I will cover the SegWit transaction in the following video, but the basic concept are almost the same. So here is the transaction which is sending from this address. This is the input, and this is the output. So two different addresses, actually both are spent. It's so the total input is 26.99 and total output is 26.98. As I said, the difference will be the transaction fees. So the transaction fee here is 0.00339 BTC, and divided by how many bytes it has. So it will be 1,520.175 Satoshi per byte. Here, estimated BTC transact, which means given a transaction you're seeing, you don't know which output is the transaction the sender wants to send to, because it could be sending to himself for the change, right? This is called the change address, but the change address may not be the same as the sender address, since a lot of the wallet can generate on the fly the public key for anonymous purpose. So just looking at the transaction, you can only guess. For example, for this one, the 4 Bitcoin is the actual transaction he wants sent to, and the 22 98 is the change to himself. So let's dive into a little bit more about the transaction. So this is the transaction which we just solved. This is the raw data of the transaction. And here you're seeing here, this is the input, and this is the previous transaction ID and the previous output index. This is the index 1, and this is the signature and the public key, which used to prove that you are the owner of the previous output. I'll talk about this later. And this transaction has two outputs, which send into two person. Okay, here you can see that so this one has value 4, the 4 Bitcoin, and this is 22, and this, the script pub key, is actually what we just talked about, is the receiver public key or receiver Bitcoin address. But it's not just address itself, it's actually a script which will be run by the miner. I'll talk about this in detail. So if we take a further look at the transaction ID here, which referencing to a previous transaction, the output index 1. So I just open this transaction 06EE, right? 06EE. And the output has two indexes. The index 1 has this value, which matches what we saw from the input. And this is the script pub key, means if you want to redeem this Bitcoin, what the script need to be run. So it need to be run without errors. So let's take a look how to run the operation in the script, what language it is and how it works. So I just copy the script signature and from the input of the transaction, and the referenced output script public key, this one, into Notepad. So this is the input and this is the output, which the input references to. So let's see how the script language works in order to redeem the coin and prove that you own the coin and you can spend the coin. So the Bitcoin script language is, it doesn't have a name, it's just called scripting language. And the design goal for this language is it has to be simple and compact, and it is a stack-based language, which means you put, if you have ever done a project like a calculator, you know what I mean. So you put the operand into the stack and you put the operation into the stack. So once you put the operation into the stack, it will actually get value from the stack and operate it, and it remove from the stack after it's done. So it's similar to that. So the Bitcoin script language is inspired by a fourth language, and it provides some operations which is cryptography operations. And the beauty of this language is it limits on the time and memory, and there's no looping. So it guarantees the script will run and ends in a certain time. So the way how it works is the Bitcoin software, which runs on the miner, will concatenate the input of the transaction with the previous output of the transaction, which the input referencing to. So here it will put the input of transaction, the first 03044 blah blah blah. This is the signature, and second part 0 to F blah blah blah. This is the public key, and then the operation is operation duplicate operation hash 160, and this is following is 601284 blah blah blah. That's the public key hashed, and then another operation called equal verify, and then another operation to check the signature. So the stack-based operations or stack-based scripts works like this. So the first it got is 3044, which is the signature. So it grabbed the signature and put it at the bottom of the stack. So this is the signature, and then it put the public keys on the stack. This is coming from this data, and then is the operation duplicate operation. So what the duplicate operation does is to get the item on top of the stack and duplicate it. So at this time it will have another public key on the stack, and the hash function, what it does is it will get the top of the stack and calculate a hash 160. So once that is being executed, the top of the stack is not public key anymore. That is the public key which is hashed, and then it got a public key hashed. So that's the data which the output transaction. So whoever want to send a Bitcoin is providing what public key, the hashed public key I want to send to. So this is from the script of the output. So we just put the data here, and then the operation to verify. So what the verify means, what it does is to get those two values from the top of the stack and check if they're equal. So this is the equal verification, verify. So what is, if it's run successfully, it will remove from the stack of those two public keys, and it's verified they're the same. And at last is the signature check. So what the signature check, what it does is, since on the stack I have the public key and the signature, and I have the transaction. So in previous episode we've discussed this, how the digital signature works. So you have the public key, you have your signature, you have the data, so that you can verify whether the signature is valid, and whether the public key, since we already compared the public key, is the one the whoever sent the Bitcoin to, so that once the script executed successfully, so that you can claim, say, I'm the owner of the public key, so that I can redeem the Bitcoin. The transaction we just saw is the V1 transaction. You can see the transaction version in the metadata. And since the transaction is 2 years old, it could be a little different from most of the transactions you see nowadays in the Bitcoin network, because most of them is V2 already, which support the segregated witness. There's a little bit different. We can talk about this in next video. Thanks for watching. Subscribe if you like it. See you next time.